Hi everyone, thank you so much for coming. We're going to get started. So we want to thank Glimpse so much for, oh wait a few seconds. All good. So we want to thank Glimpse so much for being such a gracious host. We're going to start off tonight with a few words from them so they can talk about their company and their open roles. After that, we're going to go into a lightning talk, and this is something new for Seattle Women in Data Science, where we want to start leading our technical talks with a lightning talk from someone to share for a newer speaker to share their work, get feedback. And so today our lightning talk is Abigail Schindler. She is a neuroscientist and PI at VA Puget Sound at University of Washington. Her academic research focuses on traumatic stress and systems biology. She's interested in precision medicine, mobile health, and tech for social good. And our main speaker is Rachel Tapman, and she's a data scientist from Kaggle. She probably needs no introduction. She does a lot of speaking events for other meetups, so we're very, very lucky to have her. So thank you so much, Rachel and Abigail. And without further ado, a few words from Glimpse.
Hi, thank you for coming. Just really quick, in that white fridge, there's some LaCroix and sodas if you've been wondering where all the beverages are. I'll be very brief. What is Glimpse? Simply, we're a location sharing service. We integrate with companies that work in the field service industry, so like your cable tech provider, your lawn care, your pest control, those are your field service companies. We work with roadside assistance companies, delivery, retail, grocer to offer location services to their platform. So for example, one of our customers, we work with, AAA isn't on the slide. We work with AAA, so they're a roadside assistance company. Oh, they are? Yeah. Okay, no, they, if you're on the side of the road, you're waiting for that tow truck to come or someone to come help jump your battery. It's a stressful time. We relieve that stress with our location services because that roadside truck, the assistance truck, they can share the location, they know where they're coming, they know exactly where their customer is, which is great for that type of situation. Papa John's, we all know a delivery pizza tracker. You can watch your pizza coming to your home. We all know how important that is. And we got our background with like cable companies because nobody likes to wait for your cable tech, so we narrow those waiting windows. So we're really about customer experiences and creating the best experience possible. So that's us in a nutshell. Location, great customer experience. Working at Glimpse, we're a great place to work. We have an amazing team. We do quarterly hack nights, quarterly hack nights, which are a lot of fun. I am on the marketing team, so I don't really participate, but I come and hang out, see what everyone's doing. Lots of happy hours. I absolutely participate in that. And we just did a recent team outing to a Mariners game. We're a dog-friendly office. Had you all been here before 5:30, there would have been a couple dogs running around. So yeah, we're a small, fun team. We have all-hands meetings every Monday where our CEO or our team members give us updates so we all know exactly what's going on. We've got a fully stocked kitchen, generous PTO, and you should apply to work with us. And Vanessa's going to tell you more about our open positions.
Thank you, Rena. She gives a better elevator pitch for Glimpse than I ever could. No, it was wonderful. I work on our services team, so we have some highly scaled distributed systems, and so I work on all of the backend services that are written in Go and Python here. We have a couple of positions open on our services team, and they're between mid and senior if you're interested in working in Go specifically. if you are interested in other software processes like PubSub subscription services and orchestration and open source projects, you've worked with Amazon Web Services. What else might you need to know to work here? We have a really close-knit team. We work on project roadmaps, and we move pretty fast. It's a really fun way to get a footing and work together with a number of bright people solving problems creatively. We have a new role opening up for a data engineer. This job description might change, but it just went up at glimpse.com/careers/data-engineer. I'll post it into the meetup group if any of you are interested. Basically, we're working to develop better reporting solutions, data warehouse, data pipelines, just a platform that allows our customers more ownership over data privacy, and we want to essentially make our reporting more efficient. Glimpse actually has a really interesting history as far as data privacy goes. Being one of the earliest ways to share your location from a mobile device, Glimpse has always kept like a very strict TTL on personal data. So if you provide your email address to Glimpse, it is only tied to your location stream for less than 48 hours. And that has always been true throughout the history of the Glimpse product. We do keep some location data in aggregate for other uses, but there's very, very little private data of yours that is ever stored by Glimpse. So it makes it pretty easy to integrate with GDPR and other privacy concerns that are starting to pop up. And we just want to make sure that we continue to be good corporate citizens in that regard. We are looking for someone who understands big data design concepts, ETL, different types of databases. We do have quite a bit of data in MongoDB, but we're migrating a lot of it to PostgreSQL. And whoever comes on board with us will probably have to be working with our cloud platforms. We do almost everything through Amazon Web Services, and we also do have a Databricks subscription, so if you're a Jupyter Notebook fan, that's a really great way to work together with our customer teams and the other teams that handle reporting. So if you're interested in learning more, please feel free to talk to anyone around here who works for Glimpse. Zach back there, who works with me on the services team. One of our front-end developers, Kate, is here, but I think she might be downstairs. And Brenna is our marketing person and all-around Glimpse leader. You can also always email jobs@glimpse.com, and we're all over the place. We're easy to find. You can even stop by. We're here until 5 every day. So yeah, anybody have any questions about Glimpse or about the open roles we have? Awesome. Well, we'll keep it short and sweet then. Thank you very much for coming to our office.
I forget who's first, but the lightning talk starts. So I got really excited.
Yeah.
All right. Here we go. Cool. Yep, we're good.
Hi. Okay, awesome. So thank you for the introduction. My name is Abby. I am a neuroscientist by training, but I am increasingly getting retrained in data science, and hopefully within the next couple of years, we'll move into a health data science role. And this is kind of one of my passion projects that I'm going to be talking about today, about Seattle's Find It, Fix It app. And so I'm curious who here has used or knows about the app or has used it. Okay, cool, a couple people. And so this is all in Python, and this was my foray into natural language processing. And I work for the federal government, so I need to put this at the bottom. None of these anything I say is representative of the federal government, the VA, the National Institutes of Health, et cetera, et cetera. So I have two alternative titles for this talk. The first is how a Facebook argument accelerated my plan to learn NLP methods. Next year, I'm planning on doing a electronic health records project. And so I've been, knowing that I need to increase my natural language processing skills. And I wasn't planning that until next year. And then I got into this Facebook debate, as I'm sure a lot of people are familiar with. And that kind of accelerated that plan. And so I came into this data set and this Find It, Fix It in Seattle and the issues around homelessness and what we're experiencing in this city with a lot of bias and a lot of, I like to call realism, some people would call negativity bias. And a lot of those assumptions actually, by looking at the data, have kind of been proven wrong. And so this is also, to me, a good reminder of that, like, just because you feel strongly doesn't mean that the data is actually gonna bear out those things. Oh, and then if nothing else, I love hedgehogs and cheese. And so if you're not interested in Find It, Fix It, here's a couple cute pictures. So Find It, Fix It is an app that the city of Seattle makes. Weirdly, it's only available for Androids and iPhones, not for Windows phones. But a lot of people use it, and it's been in the news a little bit recently. And the general idea is if you see something that is an issue, you can go on your app, put in the location, and we'll send it to the city, and they will then do something about it. And so it's things like graffiti, abandoned vehicles, overgrowth, and then there's this other category, which is what I'll spend most of the time on. So a couple months ago, these started showing up around Seattle. Did anyone see these? I saw one in my neighborhood in Beacon Hill. So essentially this is encouraging people to use Find It, Fix It to report people experiencing homelessness, which was not the original intended use of the app. So then someone had this Twitter post basically encouraging people to spam the Find It, Fix It. So there was people reporting like tents and REI and that kind of stuff. I posted this on my Facebook page and I got this response from one of my friend's partners, which essentially is like, this isn't what it's for. They aren't even doing sweeps reporting on this. Like, leave it alone. Let people like actually use that for what it's meant for. I'm like, I don't know if I agree with that. I don't actually think people are using this app for what it's meant for. I think people in Seattle sometimes can be horrible and are probably using it for bad things. Assumptions. And so, then I'm like, okay, well, I don't actually have the data to support that. Let me try to get that. And just as a note now, this actually I don't think was up when that was out, but now the city of Seattle has added this to their website, that it actually says that they do use information from Find It, Fix It to prioritize the sweeps that they do for the homeless encampments. So first off, they are using this. So that even more so made me want to understand how this app is being used. So what I did was do a public disclosure request to the city of Seattle, which was super easy actually. There's an online form. I put in one sentence and then someone else must have had the same request because probably 3 days later they gave me a data set. So that's cool. Now I want to do a bunch of different information requests, see what we can get. So the data set is about 250,000 entries or Find It, Fix It requests, so pretty decent size. And this is what it looks like. So you have a request number, and then the important things for me is a created date, including the time, the location, and then a description. And so this description is where the NLP will come in. And that was kind of an added bonus. I wasn't even thinking about that. I just wanted to look at numbers of requests, etc. But that's awesome. So I'm going to go through some just general exploratory data analysis, and then we'll dive into the NLP stuff. So first off, just looking at trends. And so coming from an academic background, I'm used to very big projection screens and halls. So I'm sorry, now I'm realizing that you're probably not going to be able to see this very well, but hopefully I can explain it. Essentially, this is looking at just the number of counts of requests across years. In 2019, it's only about a quarter of 2019. It's not actually a drop. If you follow the trend, it will have an increase. But basically, this app is becoming increasingly used across time. Looking at categories now, you can see there's differences in the categories of what people are selecting. And so actually the highest is this other category, which to me was not actually very surprising. The dead animal one I think is really interesting. That's a new one in 2019. I think that's actually going to be higher later on, but because 2019 is only a partial data set. And then the other high ones are abandoned vehicle, graffiti, and needles and dumping. So again, not too surprising. We can get a little more granular by looking at it by year and category. And again, you see in general, most of the categories are increasing over the years with really big jumps in 2018 in the other category and then this needles and dumping category. One more, so this we can also look at across months. So this is from January to December and then across the different categories. This is where I really started to realize people aren't using this app the way it's intended to potentially. So look at, for example, streetlight, right? You get this dip in the summer months and then you have increases when it's dark out, which makes sense. Potholes, we have the max in the spring, which is during the rainy time, or that would be my interpretation, I would say, of this. And then for some other categories, there's not really any signal across the months. And then finally, just looking at time of day, to me, this looks like it's peaking at commute times. So most likely this is people either taking the bus or walking and are seeing things and reporting them. And then obviously in the twilight hours, we get almost no requests. Okay, and then one last thing. So looking at the location data, I have not explored this a ton, but if you just do a count of the highest locations, this one location on 9th Avenue has actually had 322 requests of the same exact location. So one thing I want to do later is try to map that over time and see if using like a sentiment analysis, if the sentiment got angrier and angrier or worse and worse over time as they kept doing this request over and over again. We can also use the zip code data to map to neighborhoods. And so again, there's some differences in the neighborhoods, but not as big. Assumption again was that the more white upper class areas we're going to have more requests than the lower socioeconomic, but that is not necessarily what's bearing out. This really high bar on the left is actually Washington. There was a whole host of addresses that didn't have a zip code attached to it. So I also want to do some kind of pipeline to pull the zip codes for that too. I'm not a location person, so that will be interesting. And if anyone is interested in collaborating on this, let me know too. And then finally, this is looking at across the different neighborhoods and categories. And in general, I think the trend kind of stays where the other and the needles and dumping, this red and then the brown are highest across neighborhoods. But then there's some things like Capitol Hill actually has a big increase in graffiti, the orange compared to other ones. So a little bit of signal. Okay, so getting into the NLP. So there's a couple different things I'm going to show. First, I did a sentiment analysis using Sentiment Vader, which is just the coolest name. And then I did a very standard processing pipeline where you remove punctuation, tokenize, remove stop words, et cetera, et cetera. And then I looked at word frequency, looking at distributions and word clouds. And then finally, I tried to do some topic modeling with the Jensen, I think, library. I think that's how you pronounce it. So in this, like I said, this is my first, a lot of this I learned from blog posts, etc. And so I would love feedback. So first, looking at polarity. So this is looking at anything negative would be a negative sentiment for that write-in part. And so we can see that there is some differences. Again, not surprisingly to me, things like needle and dumping in the other category have the most negative polarity scores. And then this dead animal one just really skyrockets. I think because the word dead is probably in a lot of the posts would be my guess. And if we look just as an example, here, so this top one is the highest polarity score I got, which was like a 0.98 or something. And it's like, thank you so much for fixing this, et cetera, et cetera, et cetera, capitalization. And then this negative one is like, people are going to die. Like, this is horrible. Why are you doing this? It's about a traffic flow, essentially. So I am able to see, just with some very simple sentiment analysis, some big differences in the data, or in how people are talking about the data, at least. Looking at polarity over time, there's again this kind of trend as time goes on to get more negative. My guess is because that other category is increasing the percentage in there. And then this was another big assumption that was not proven true, is that across the neighborhoods or locations, there would be a big difference in polarity. But in general, across neighborhoods, there really doesn't seem to be too much of a change. Somewhere like the Belltown versus a Beacon or Ballard are about the same, which surprised me. Okay, so next, word frequency. Showing this is for the graffiti and then for the other category. And so nothing too surprising here. I want to go back and take out some of these like graffiti or park for the stop words and see what would come up if I took out those really common ones. Something that really surprised me in the other category though, is if you look, we have a please here, which again, really didn't go with my assumption of what was going on with this other category. You can see this play out also with the word clouds. And so this first one is for abandoned vehicles. So you get abandoned, park. Second one is for graffiti. Third is for dumping and trash. And then this is for the other. And so in this other category, you see things like camp, homeless, illegal, but then you also see this please. And I'm like, what is going on with that? Which brings me to the topic modeling. And so I did two different things to start with. The first is just looking at, and you probably can't see this at all, but I essentially just had it choose one topic per category, and it comes up with really what you think the categories are, what the categories are. So for example, abandoned vehicle, there's things park, car, weak are the first three. But again, in this other category, we have park, sidewalk, camp, encampment, tent, illegal. So suggesting that it is a lot about this, the people experiencing homelessness. Just to explore this a little bit further, we can look at the distribution here of the polarity score for this other category. Yes. And so what I noticed here is obviously we have this big bump over here in the negative, but we also have this little blip over here in the more positive. And so what I did is split those, took everything above a 0.5 polarity score and then everything below a negative 0.5 polarity score, and then did topic modeling on those two data sets. And what we see essentially is this everything above the 0.5, so this kind of tail here is essentially people thinking. It says, thank you, please. And it sounds like a lot of people thanking them for fixing things. And then this negative, below negative 0.5, we have things like illegal, camp, encampment, homeless. So it does seem like there is a negative sentiment being applied to this other category for the posts or the requests that are about people experiencing homelessness. Whereas when it's positive, they're thanking them for doing things. Okay, so that was very fast. But like I said, this project is just starting. I would love some collaborators if anyone's interested. There's so much data to explore. This is barely scratching the surface. These are my contact information. Like I said, the introduction, my regular day research is TBI and PTSD. And then again, here's some cute pictures of hedgehogs and cheese. Thanks. Questions? Time for questions.
Time for a few questions.
Okay.
So the data set, is that like available for public use, or is it?
You know, I meant to look into this because I was figuring someone's going to ask me. I would think so, but I'm not sure. I need to look.
Data collection by the government is in the public domain.
Okay, then yes. Yeah. And I know, like I said, it's floating around because they sent it back to me within days, so I'm sure other people have this also.
So I've used Penifix app. The time that I use it was to report animal waste on the sidewalk. And I'm not sure if it's the appropriate use of that app or like there's another way to take place. It's like I know there's like the downtown Seattle group that don't know cleaning up, so like,
Oh, really?
but there should be maybe dead animal slash should be like dead animal slash animal waste.
Well, you know, it's interesting. So I think that,
Animal related.
so when I took the other category and I had it do more than one topic, it actually was coming up with what I think were topics that then became their own category later. So when I showed this, so like for example, this sign signal only started in 2016. If you look at the earlier other category with the topics, a lot of those earlier ones are that. So maybe if enough,
Just send another request and say, can you please add it?
get it, yeah.
So I didn't know what else to do. Like it was a substantial. in a well-trafficked island.
Have you talked to anyone at Untitled about potential utility for the app for your research? Like, for example, maybe suggesting to someone, like, it looks like you might be wanting to call wildlife. You know? Or just in the meantime, if something sounds particularly airy, maybe a non-emergency phone number or something like that, like to provide that.
That's a great idea. Yeah, no, what I have done so far is try to get a reporter interested in the data, but it turned out to be not as interesting because again, I had these assumptions that like it's going to be this like Ballard is horrible people and I don't know why I'm selling Ballard all the time, but that didn't bear out. And so essentially the reporter I talked to is like, yeah, you haven't really given me anything that's really worth like writing a story about. So, but we'll see maybe with some more digging.
It's actually been already published without the data.
Yeah, there's been quite a few articles about it. Yeah, so that's why she was like, there's what's the new, what's my hook line essentially.
What kind of help? I mean, I think there are probably people concerned who could, if they want to work on this with you. Like, do you have a GitHub repo, or is there somebody who's helping you currently? What kind of work would you be looking for?
I do. There is a GitHub repo. It's all in Jupyter Notebooks. I would love someone that actually does NLP work or has training in that would be great. I have someone just to make sure I'm not crazy and reading Stack Overflow wrong. But then also someone that maybe has experience with geolocation type of thing. I know Google Maps has an API that I was looking into, but you can only do so many requests a day, and so it was going to take a really long time to get that. There was a couple open source map libraries that I found. I just haven't had time to try to implement them yet. But yeah, and just anyone else to look at this and be like, oh, here's an idea, or here's something. Because again, I have my own assumptions coming into this, and so more eyes is always better.
So I think it's basically geotagged, the location.
Yeah, well, because you get latitude and longitude, you have the address, and then I would love to also put it on a map to look at, like maybe again some of those requests, maybe they're all clustered in an area, where a zip code is just so wide. So okay, thank you all. I thought there was going to be like, I was going to show what my that's what I was thinking.
It's a good reminder that you can do that.
Yes, it's in the basement.
Walk into that chair. Hello, everybody. We're going to have right back on the NLP train and talk about unsupervised text classification and clustering is what that second word is, which is very similar to what? Annalise? No. Abby was just doing. Sorry, I'm extremely bad with names, so I apologize. So I have a story time. This is supposed to be me. It's not me. It's just a copyright-free image. So I work from home in the mornings and I go into the office in the midday and afternoons. And every morning I sit on my couch and I have my coffee and I have my hedgehog. I didn't realize this would be such a hedgehog. So big and sweet. His name is Gustav. And he sits with me and I check my emails. And one of the things I do as part of checking my emails is I read every forum post on the Kaggle forums every day. I'm a data scientist for Kaggle, and I have a really large part of my job is interacting with the community and filing feature requests and bugs and providing feedback to the product team. So that's a really big part of my day. And when I first started, this was like, it was a fun 10 minutes. Oh, well, I'll star these to answer later. And as I have been at the company longer, it has become less of a fun thing that I do for a couple minutes in the morning and more like a huge chunk of my day. So the growth of forum posts on Kaggle is roughly exponential. And this is no longer tenable for me to do all by myself. I think this morning I had 150. Which doesn't seem like a lot, but if you're reading them carefully and you want to give technical help if somebody's asking for it, or make sure that it's being passed to the right channels, that there's a bug report, that you're filing it to the correct bug report and all of that, that takes a really long time. And I've just sort of stopped being able to do it by myself. So how do I get away from having to do this with my human eyeballs as a person and start to use NLP techniques to help do the job for me? So I don't think I mentioned this, but my doctorate is actually in linguistics with a focus in NLP. So this is sort of my sweet spot, and in theory should be something that I could do relatively easily. I knew going into it, it would take longer than I ever possibly thought it could, and that prediction was 100% correct. So still under construction. My final it's not on this one. But my final plan is to build a Slack bot that people can write queries to and be like, hey, are there any bug reports or something like that? I'm a long way from my fantasy Slack bot that I want very much. And at some point, I'm going to have to deal with streaming data, but that's for future Rachel. So some ground rules. A big part of it is that it needed to be in Python or R. There's a lot of tools out there that have interesting dependencies. There's a lot of Perl stuff that I was not gonna touch. And part of the reason is that I actually did all of this project and continuing to work on it live. I do it as part of live coding. I stream every Friday. So if you want to tune in tomorrow, 9 a.m. our time. And the only two languages that we support on Kaggle notebooks, so Kaggle has hosted notebooks, are Python and R. We used to support Julia, and then nobody used it. And every so often someone in the forums will be like, where's Julia? And nobody used it. Nothing against Julia. So I really wanted to avoid Java, C++, MATLAB, any proprietary languages, not that Java or C++ are, that I know. It also needed to be really fast and able to handle new classes. So I don't know how long y'all have been in machine learning, but if it's been more than a week, you've probably noticed it tends to move pretty fast. So the NeuRT papers are out, everybody's talking about, the new thing, the weight diagnostic neural networks or WANs, whatever it is that they're talking about, and it goes really snappy. And also bug reports. Hopefully we fix the bugs real fast, and then the next bug report is on a different bug. So I don't want to spend a lot of time handling new topics and then find out, oh, hey, those were only good for 2 days. Also, at some point I might not be at Kaggle anymore, and I want this to continue to work without a lot of sort of human munging. I'm going to probably have to rerun it at least daily. Like I said, we probably get between 100 to 300 forum posts a day, excluding posts on competitions. I don't look at posts on competitions, and those are one of the more active parts of our site. And eventually I do want to do this streaming. So if every time you get a new forum post, you retrain your model, that's not a great use of your time or compute or money. I also wanted to avoid large, weird dependencies, particularly if they were under licenses of not questionable legality, but I don't want to meet with lawyers, man. I just want to use something that's under licenses that I'm not going to get yelled at for using. And also, I don't know if you've ever tried to convince a software engineer, if you're not a software engineer, that they should totally just download this jar that you downloaded and just sit in there. It'll be fine. It'll be fine. Somebody wrote it in 2018. It's fine. I also really care about interpretability because the end user here is me primarily, so I want it to look good to my eyes, but also my teammates. I want to be able to be like, hey, kernels teams, there's a bunch of, kernels is what we call our notebooks. There's a bunch of bugs around something with loading in data into kernels, take a look. So I did, when I was starting out, what I always do when I'm starting a project, and that is I ask questions on Twitter. Going into it, there's a lot of topic modeling techniques where you don't necessarily have to provide what the topics are ahead of time. They tend to be slow and have other drawbacks as well, but that's one thing that I was talking about. But I was also thinking about more general clustering techniques. They don't have to specifically be topic modeling because I didn't necessarily need topic labels out, if that makes sense. If I could have on some other sort of interpretable information about the text that wasn't like, this topic's about dogs, I was fine with that. So the original 3 things I was looking at were LDA, latent deer-clay allocation, which Abby mentioned in her talk, embeddings and clustering. Have y'all, everybody close your eyes. Raise your hand if you have not heard of embeddings or word vectors. All right, everybody put your hands down. Open your eyes. Thank you, that was helpful. So the idea with embeddings is that you take a co-location matrix of your vocabulary. So you have all your vocabulary words on this axis and all your vocabulary words on this axis, and you count how many times they occur, and then you take that really big sparse matrix and project it down into a smaller dimensional space, so that in this usually 300 to 500 dimensional space, words that are used together more often are closer to each other. So you'll have like an animal cluster. And this is a super, super common way of handling the fact that words mean things. So instead of doing semantic modeling, you use these embeddings as sort of a proxy for meaning. And then k-means clustering, which is a pretty common clustering technique that I did not end up using. Spoilers. And also this method that I was interested in trying out, unsupervised keyword extraction, specifically using the Yake algorithm. And I'll talk about that a little bit more. And I got lots and lots and lots of feedback and good ideas. And the 3 sort of main bins that the feedback I got fell into was end-to-end solutions. So programs that somebody had written who did the whole thing. Suggestions for different types of feature engineering and then clustering techniques, and then also just various tips and tricks. Many of my Twitter followers are also in NLP, as I suppose that's not surprising, homogeneity of social networks and all that. And so a lot of them were like, oh yeah, one time I took a PCA and then I removed the first principal component, and then I used the rest of the components in my analysis, and it worked really well. So that's a cool thing, you might try it. I didn't end up trying it. So the end-to-end solutions. Gensim, which also Abby mentioned. Some benefits, it's in Python, no weird dependencies. It's a favorite in the community. There's a lot of different methods. A sort of like model of Gensim is that you can pay the author of Gensim to be a consultant on your project, and that's how he eats food. Doesn't need the whole corpus in memory, so it's really designed to work well with streaming projects and work well with like enterprise level stuff. But it's under LGPL, which is one of those licenses that I probably fine, but I would have to meet with a lawyer, and I prefer not to. So I just sort of kick that to the side, especially for prototyping. I didn't want to build a whole staff and be like, oh, now I have to have lawyer meetings. Ugh. Our legal counsel is great. I love you, Linda. Another end-to-end solution was Big RTN, which I had never heard of before. And I think this one's out of Yandex, which is a big Russian tech company. And a nice thing about this is that it can incorporate multiple objectives at once. So it can do a lot of things. And if you were like, hey, I want this to be like smooth and I want to do decorrelation. At the same time, you can do multiple things at once. It's got some weird dependencies. It was like built on a stack that I had never touched, and I was like, okay, something else. I had lots of options to go through. Another was Top SVM. This might be the one that's by Yandex. One of these two is by Yandex. And somebody I trust recommended it as scary good. But again, weird dependencies. And a graph tool is not that weird, but I couldn't get it working after like an hour of work, and I was like, yeah, whatever. I have lots of other things that I could try. So feature engineering, the big problem in feature engineering in NLP is you have words aren't numbers, both algorithms do want numbers going into them, so how do you take your words and turn them into numbers? Some of the traditional topic modeling approaches, LDA, not my favorite, slow, hard to interpret. I've used it a couple times before, and it's just like, it's fine, it's not my favorite. PLSA, which is a cheaper version of LSA, which LDA is an extension of blah, 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 blah. You don't need to do all the details. This is all very Googleable, but it tends to overfit. So I wasn't super excited about that. And then TF-IDF, which is term frequency inverse document frequency, which y'all get in your intro NLP courses if you've taken those. And hard to interpret. The clusters you get out of that are like they're weird. And also they don't tend to work well with short posts. The longer your documents are, because it depends on the document frequency, the better results you get. If you have somebody saying, thanks, smiley, that's the TF-IDF is not gonna handle that very well. So I sort of put aside a lot of the traditional topic modeling approaches. Embedding, so this is that way of you codependency to project it down. Couple options here. So Glove, which is out of Stanford, is one of the older embedding platforms or algorithms. It considers context, which is nice. It's contextual embedding, similar to, I don't know if y'all have heard about BERT or GPT-2, or the idea is those are very contextual, and this also considers context, but not to the same extent, because they didn't have, $15 million of compute or whatever it was they ended up using. Word2Vec, which is out of Facebook. Yes. No, Word2Vec is Google. FastText is Facebook. Yeah, thank you. Y'all got my back. The benefits of Word2Vec doesn't handle small corpuses super well, but it's very fast to train. Did I mention the corpus that I'm using? Yeah, it's a Kaggle forum post, basically. That's my corpus. And I think we had about 500 million words in-ish there. I might be off by a 0 because I do tend to do that. So not a super duper small corpus. And very fast to train. And I did end up using Word2Vec because then I took the existing embeddings and then I updated them using the Kaggle forums. I'll talk about that. And then fast text, and the big benefit of fast text is it can handle out of vocabulary words. So if there's a word that didn't show up in your original matrix, like on either of the edges, or both of the edges, I guess, fast text can handle that because it does a little sort of morphological breaking apart. So if it's never seen the word apples before, but it knows about apple and knows about, it can handle that by plugging them together. And then contextual embedding. So these are the BERT and Elmo sort of models. I consider them more language models. I know that I don't want to. How much NLP experience does this crowd have? Okay. Yes, I would say some things about this, about these models that other people would disagree with, and that's the whole point of the aside. And then universal sentence embeddings that I didn't end up using, but are super easy to use. So usually you do embeddings at the word level. Universal sentence embeddings, you send a sentence in, you get an embedding back. The reason I didn't use this is that it's in base TensorFlow, and I would prefer to avoid base TensorFlow because I don't like it. It's very complex. So the things that I was originally interested in using here were Word2Vec, fast text, and use embeddings. And I have deleted a slide. And then dimensionality reduction. So if you can imagine, you've got your text, you know where each word is, you've got a vector, a word. Okay. So you have your text, you have your list of word vectors for all of the words in your vocabulary, right? How do you take like a sentence and turn it into a single vector if you're not using something like universal sentence embeddings that does it for you? A couple of ways you can do it. One is to say that all of my sentences are 300 words long, and if there's extra words at the end, they're just zeros, and then the first dimension in your matrix is the embedding for the first word. Let's say it's the, and then the second one is the embedding for the second one. Let's say it's hedgehog, and then the third one is the embedding for the third word, and the rest end up being zeros. That gets you a really large, very sparse matrix. So there's usually something that you need to do to take your big sparse matrix and turn it into a smaller matrix. And there are many different ways of doing this, like document embeddings. But the one that I was most interested in was UMAP. And I didn't realize until I was looking into the technique that the person who recommended to it was the person who developed it. Also, other people agreed. It wasn't just one guy being like, oh, use that method, it's great. He specifically suggested using heterogeneous. It's sort of similar to UMAP. It's sort of similar to TSNE. I don't know if you guys have used it. It's basically a way to visualize a high-dimensional embedding space. And then I looked at the paper and did not follow it. Something about topology, manifolds, shapes. If you guys have a good understanding of UMAP, I'd love to hear more from you. And then I was sort of interested in looking at that PCA trick that I mentioned earlier, where you do your dimensionality reduction and then you get rid of the first one and you only look at the other ones. All right, and then YAIC, which I mentioned very briefly earlier, and there's actually a paper about this that just came out that I tweeted about, so if you're interested in learning more about it from the original authors of the algorithm, you can do that. And this I would consider a dimensionality reduction technique.
it takes a span of text and picks out the most important words. So the benefit of this is that if you're doing something like creating a matrix where you're filling it in based on the number of words, if you have fewer words to begin with, it doesn't take as long. You can toss a lot of your data. And there was some pretty compelling evidence. This is a little bit small, but this is a news story about Google acquiring Kaggle. I don't know if you knew that, but Google owns Kaggle. And some of the keywords were Google data, Kaggle, platform data, machine learning, CEO Anthony Goldblum, San Francisco, Ben Hamner, who's the CTO, Kaggle, Google, platform, Kaggle, Google. So I think it does a pretty good job figuring out what the importance words are and then giving it back. And this, I haven't updated this slide in a minute. I have played around with it, and I did get really good results, and we're gonna take a look at some of those. So also very fast, which is something that I found out later, compared to some other keyword extraction techniques that I've used. So if you have text data you want to try it again, see if you like it. I did not end up using this at all, but I still think it's a really cool idea. So the idea here is that you do LDA, which is that topic modeling that's not my favorite, but what you get out instead of a sort of incomprehensible list of words is a vector, right? So you are training your embeddings and your topic models at the same time and they're feeding back into each other. And this was developed at Stitch Fix. It's kind of been abandoned as far as I can tell. I don't think it's necessarily still under active development, but I think it's a cool idea. So if anybody wants a project to adopt, this might be a cool one. And then clustering. So some of the clustering ideas here, ground clusters, you may not have heard of these. These are specifically for text data. And the idea is that you take, in your vocabulary, you look at n-grams, usually bigrams, and the relationship between the two words in the bigram is the amount of mutual information between them. So if they tend to get used together a lot, but not in other places, then they have a high score. So if people say Kaggle kernels, Kaggle kernels, Kaggle kernels, but never popcorn kernels, then Kaggle and kernels will have high mutual information, and popcorn and kernels will have lower mutual information. But the will always have very low mutual information with the word because it gets used with everything, right? The apples, the hedgehogs, the cheese, the kernels, the Kaggle, etc. That's the idea there, and I'm talking to you about it because I did it. I tried it. And then other sort of more standard clustering techniques, DB-scan and hierarchical DB-scan. If you're familiar with clustering, you probably run across these. If you haven't, there's lots of good resources on the internet. And then spectral clustering, which I did end up using. I have another slide later on. But the important thing about spectral clustering is that it's inside Hitler, and I was using Python, so I didn't have to deal with implementation. So at the very first stage, when I was starting to scope out what this would look like, I put together a bunch of different type bindings that I might have tried to see if they worked. And the first one that I tried was Yank, so keyword extraction, and then round clustering. And round clustering works on the words themselves. You don't actually need to turn them into numbers. I was like, oh, this is cool. My output will be really interpretable, just based on like words I can understand really easily. And this is just an example of a post before I did keyword extraction. You don't got to read this, but it's blah, 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 chromosomes, something, something, DNA. And then the keyword extractions from this was machine learning part, machine learning sequences, represent coding sequences, interested in making protein sequences, glad to collaborate, making a two people team, learning part, etc. So it went through and extracted the information that somebody was looking to build a two-person team. They were interested in teaming up with other people, and then they were working with something DNA sequences and machine learning. I think that's pretty good keyword extraction from that text. I get a good idea of what's going on in the text without having to read the whole thing, so I was a fan of that. It was also about 20% as long. So again, a dimensionality reduction. And I do have a couple of stop words here. So if you're not familiar, stop words are very small, usually small, common words that you generally remove from text during NLP processing. So like the most common word in the English language. Usually you take that out. It's not very informative. In, you usually take out. To, you usually take out. So particles, things like that. And this removed most of the stop words, so it's sort of like a free stop word removal, and that's kind of cool. And then the code for this example is linked here. And you can see the full code for this. It's pretty straightforward. It's a nice to use library. I would recommend it. All right. Then I did ground clustering, which if you'll remember is that I got pi grams and I'm doing the mutual information measurement with them. So the first thing I did was I trained my clustering. It took a really long time. In the original paper, they were like, yeah, don't do this with a vocabulary of more than 5,000. My vocabulary was definitely more than 5,000, and I think they were meaning when they gave me that advice because they were correct. So here is the clustering of words that are similar to Kaggle, so have high mutual information without the keyword extraction. So R, href, people are linking to things on Kaggle, is to S, and M, do also here. So not super informative. But with the keyword extraction, I got really good, interesting results. So the words that had high mutual information with Kaggle are kernel, again, that's what we call our hosted notebooks. Dataset, we host datasets. We should hope that people are talking about datasets on Kaggle. Nice, competition, import, features, HTTPS, so people are still linking. Make, kernels, and this. So pretty happy with those. That seems like pretty good extraction of words that I would expect to be used with Kaggle. So very informative. Oh, it's wrapped weird. Bad news, and there's quite a bit of bad news. So the biggest piece of bad news is that the library I was using was an academic project that someone was working on, and they didn't finish the implementation. So you could train your clusters. There was just no way to get the clusters out once they were trained, and what you got instead was just like a list of words. And I eventually figured out that the words were actually in the clusters. They just all been added to the same data structure with no hierarchical structure. So you had to find the breaks between them and then insert the breaks. And I did that. I did figure it out. It was painful. You can watch me do it on YouTube. I wouldn't recommend it. Again, very slow. The author's like, hey, don't use this for big vocabularies. I did use it for big vocabulary. So who's the fool now? It's me. And I spent quite a bit of time tuning, and I just did not get very good clusters. So these are sort of samples of the clusters I got. I have a cluster here, which is A, training. So it's 2 words. Those are the words in the cluster. In train, dataset find problem, which I guess that's an okay cluster, but I would expect slightly more information about the cluster, you know. Make with, okay, I guess. Error learn. So they're not, you know, they're not awful, but they're not the sort of informative, interpretable output that I was really hoping for, and that I really wanted to read on my couch every morning with my eyeballs in my hedgehog. He doesn't read. So the next step was, all right, that's clearly not going to work. All right, I'll use the vector-based methods. So I did a new method, and I sort of took out this middle step of doing dimension reduction in a smart way, and I instead did it in a very dumb way, and we'll see about that in a second. And I used word-to-vec and then spectral clustering. So just using sort of one of the embedding techniques and then one of the clustering techniques I was looking at in the first place. So word-to-vec. The reason I chose word-to-vec over fast text, which is the other one I was looking at, fast text can handle out-of-vocabulary words, but it requires a little bit more pre-processing. And I could tune word-to-vec. I'm actually using Jensen, which I don't think I have. I don't have my imports here, but these methods are from Jensen. And so I took the pre-trained 300 word-to-vec vectors, and then I tuned them on the Kaggle corpus. So the Kaggle corpus being all of the Kaggle forum posts up to that date as of August 19th, 2019. And it's a pretty chunky text corpus. It's not enormous, but it's pretty sizable. And then I saved them. So I only have to do this once, and I can keep using these embeddings downstream until they get to the point where they're no longer super relevant. So maybe like a year. But still, they took maybe an hour. It wasn't that intensive, and I didn't parallelize or anything. It was just on CPU, so not too bad. All right, the document embedding. So I mentioned that usually, you know, you've got your sentence and you have like a fixed length, and there's all sorts of dimension reduction techniques you can use that are smart, but I didn't use any of those. Just because I wanted to, this was again just very proof of concept-y. So I took the embeddings for each word, and then I stacked them on top of each other, and then I took the average. So the idea is that you kind of are sort of close to the center of mass of the sentence in your multidimensional space. This is something that could be improved on, again, prototyping. So that's the other thing I did. And then once I had my vectors, so each each document, each forum post was now a vector of like 300. I did spectral clustering. And the reason that I chose spectral clustering in particular is because it can find non-contiguous decision regions, which is really, really nice because I didn't know, right? Especially if you're in a very high dimensional space, things tend to get weird. Spectral clustering can handle very sparse matrices pretty well. And this little example here is sort of showing you why spectral clustering is something you would use over something like k-means. So here we have the original data distribution, which is sort of like a bullseye. We have one group in the center, one group around the outside. With k-means, the best you can do is sort of draw a line through the center. K-means can't, divide the decision region into a bullseye shape, but spectral clustering can. And spectral clustering is a graph-based method. There's a number of ways of doing it. The simplest implementation is that you calculate the pairwise distance between all of the different points, and if there is a very small pairwise distance between two sets of points, you stick them in the same cluster. If they're close, they get stuck together. That's the general idea. And there's other implementations that are fancier and harder to put in a single bullet point. There's, again, very good resources online if you're interested in learning about this. None of which I link to. You'll have Google, I trust you. So another thing is that it doesn't assume similarity between the groups, which again, I think that posts about a specific bug are going to be very similar because people are going to be posting error messages. I think posts about like learners asking questions as they come into the community for the first time is going to be a very diverse group, right? So I wanted to be able to sort of tease apart those distances, those differences. And the biggest benefit for me is k-means you have to specify k, right? Or train several models and then find the elbow, all of that nonsense. You don't need to do that with spectral clustering. It's emergent. I mean, you do have to specify a maximum number and then it works from there, but you can end up with empty clusters, which is really nice. So that's why I use spectral clustering. And it worked really well. So this is a cluster from data from Tuesday, maybe. So this is the whole cluster, and it's just this beginning part of the posts. And it seems to be mostly about running kernels. So this person added this kernel to my favorite list. How long does it take your code to run once? Click on the run option of the notebook. Google Colab, max experiment time is 90 minutes, so that's how long it'll run. Things CPMP, that's a Kaggle. Here's a fun result of my CAG. I'm assuming it says Kaggle kernel after that. I just launched a kernel at night, woke up 7, ... Unfortunately, I'm not able to probably replicate, and so on. And it's not completely homogeneous, so this person talking about receiving a certification, not exactly in the cluster if I were making them as a human, but I think pretty good, solid results. Another thing that is very nice about all the methods that I've used is that because I am tuning on data from all of the Kaggle forums and people don't just post on English, it's able to handle other languages that we've seen before. So here we have a cluster of like Turkish people being polite. So I looked at these and it's basically, hey, nice work, man, good job, congratulations, that sort of thing. And then we have like the one nicely explained English post that just sort of got in there, and then the one thumbs up emoji that also sort of got in there. So I'm really happy with this as a cluster. I don't think I would have been able to do this as a human being, so 10 out of 10. And then there's this one which is a little bit bigger, and it's just sort of like questions and answers. So this person is, what is the decryption key? What is the difference between Y and target? I have a question on assignment 1.2. Here is a simple solution. Good job there. I've got one suggestion. How do you calculate the number of fraud per day? Excellent question. Just sort of questions and the people answering specific questions, and this is fantastic. This is something I'd be perfectly happy to label and then send to somebody as like, hey, people are interacting in the way that we want them to. So right now, this is what my pipeline looks like. I use my tuned word-to-vec embeddings that I tuned, that I could retune if I needed to. Then I do document embeddings. That's an area for improvement. And then I do spectral clustering. And the part that takes the longest is figuring out the embeddings for each of the documents. So getting the word embeddings and averaging them down and switching them down again. All of this code is open and public source. It's under 2.0. Any public notebook on Kaggle is licensed under Apache 2.0. So I think it says it on the kernels page as well, but just FYI. And if you're interested in looking at the different code that I wrote, here is the one for fine-tuning word-to-vec. Obviously, I don't run that every time because that takes a minute, more than 1 minute. And then here is the final pipeline, including some additional work I did on summarization. So once I get these clusters out, obviously I could read every post in every cluster, but this is not actually a time savings. I have to have a way for the information to be reduced. I don't want to have the map of Peru problem. And then here's the live coding recordings if you want to watch me do this in real time. Although now that you know the answers, it might be a little bit less exciting. All right. Any questions? Yes.
I'm just wondering what the live code recording is like. What's the channel for this?
Oh, it's on Kaggle's YouTube.
Okay.
It won't let me. Okay. Cancel, I guess. I don't want to get anybody in trouble if this is work laptop. Yeah, and they are at 9 a.m. on Fridays. I do live coding, and then 9 a.m. on Wednesdays, I read machine learning papers, which people watch. I still can't believe it.
So you said the document embeddings, you said it's area of improvement. Are you looking at like new map or something to reduce the dimensionality? Is that what you were talking about?
Yeah, that's definitely one option. I would like to get the universal sentence embeddings working because it does the embedding step and then the next step together. The biggest problem with that is that it's not going to be able to handle Kaggle-specific vocabulary. So I guess, I should try it and find out, right? I think that's the next thing that I want to try if I continue to work with the pipeline. Although, again, I do want to build a Slack bot, and I do want to build like alerting, especially once I get streaming going. And I also want to build, like, just for me, a bot that tells me when there's a question that I should probably answer, because I have, like, weird flex, but I've answered more questions on the Kaggle forums than any other Kaggle employee. So I've got a lot of training data. I know what type of questions Rachel's liable to pop up and answer. So I think that would be a really useful thing to build. And it's sort of, at what point am I going to get big enough improvements in the NLP algorithm that it's worth not spending the time building those other things that are going to be also useful? So it's not that I don't want to try everything and go back and, like, do another playthrough. It's when am I going to start seeing diminishing returns? Yeah.
So you're gonna train a simple model where you just take all the posts that you replied to, all the posts that you didn't reply to while you weren't here, and then just say, "Oh, look at that. Respond to this question."
Yep, that's the thing. Yep, it's my whole plan.
It sounds like everyone did.
That's.
Did you try HDB scan?
I did not. I think it's not in sklearn, and that's the reason. Yeah. Maybe it is, and I just didn't look hard enough. But I'm pretty happy with the clustering. I'm not upset with it. So.
What was the question?
Did you try HDB scan?
HDB scan, one of the other clustering techniques. Yeah.
Do you share the slides anyway?
Oh, yeah, for sure. There's a version of the earlier ones on my website, but I thought I had full intention of going through and doing another editing pass and making them look prettier today, and it did not happen. Unrelated, I'm secretly running an event next week, so if you subscribe to the Kaggle newsletter, keep your eyes open. So there's reasons. But yes, I'll share these on my website, which is rctapman.com. Yes.
Can we also share them on the meetup?
Please, feel free. Yes.
Is the data set available?
Oh yeah, of course. So that's actually a really good question because I was thinking about the fact that I had not mentioned this anywhere. So the data set is called MetaKaggle, and it's a data set that Kaggle makes public, and it's sort of all the data about Kaggle and Kagglers that is not private, so it's only public data. One sort of wrinkle of MetaKaggle in particular is that we update it every day, and if any data has been removed for whatever reason, such as GDPR, it gets removed as well. So every time you open a new kernel on this data set, it's going to have to reload in the data and restart, and that does take a minute. That doesn't happen with all our data sets, but for data privacy reasons, obviously, we do it with yeah. Also, if you've never tried Kaggle data sets, we've made lots of changes. I don't know why you'd know about the changes if you've never tried it, but if you haven't used it recently, we've made lots of changes. Good changes.
If you did want to put in any of those links, I think it's a demo laptop and it should be really clear.
Okay. I can just like open whatever. Okay.
Links into the meetup group so people can check this out.
Yeah, definitely.
What's it like having a hedgehog?
The question is, what's it like having a hedgehog? It's a very interesting pet. They're nocturnal, which is one important thing that you should know. They're not going to be awake while you're awake. They're also pretty dumb. I would say they're less smart than a rabbit. So they are not, for example, trainable. I've tried it. It doesn't work. They're very nice. They are exotics. There's a pretty stringent care requirement. The biggest thing is they can't get too cold. Domesticated hedgehogs are African pygmy hedgehogs, and they're native to the Sahara. So they don't have the ability to build up the fat reserves necessary to hibernate successfully, but they still have the genetic inclination to it. So if they get much below 75 for an extended period of time, they'll just sort of go to sleep and never wake up. So making sure that you are doing like really good husbandry, and making sure they're getting enough food, and that also the temperature is extremely consistent is very important. Not all of them like being handled. We're lucky in that our little guy does, and we also handle him consistently. So if you do get a hedgehog, you have to play with it every day. That's the rules. Otherwise, it will never want to be touched. Because they're prey animals, right? They're small, they're vulnerable, and their one defense is to make themselves extremely unpleasant to be touched. So if you don't get your cuddling in, you're never going to. Yeah, that's my hedgehog spiel. I love him very much. Oh, and the other thing about hedgehogs, looks like everyone's done eating, they love wheels, but they won't get out of the wheel to poop. So you'll come out in the morning and it'll just be sort of like, coated, and then they've got little boots on their feetsies, and yeah.
I recently was talking to another hedgehog owner who has a solution to that, which is, and I can send you the link, but it's essentially like sticky plastic wrap that he puts on the wheel, and then every morning takes it off.
Oh, he takes off the plastic wrap. Oh, okay. Oh, we just wash the wheel.
I do too, but it's gross.
I grew up on a farm, so my gross meter is very poorly calibrated. I was like, oh, it's small. It's not that much. So, but, yeah, hedgehogs are great.
I like the presentation as far as the reason why. Part of the reason I liked it is because you ran through all your every kick of the can that you did, and you just discussed it iteratively, like each and how you iterated through, and that was very helpful. So,
Yeah, good. I'm glad to hear that. I feel like a lot of data science work, especially when it's gets shared out, is like the, here's one I made earlier sort of version, which I don't think there's anything wrong with that, but it's nice to know about people struggling. Because it's okay, I messed up.
it was an insight into your method, your methodology, just how you approached it, and that was great.
Thank you. I'm glad you found it valuable.
So when
Yes.
you started streaming on YouTube, I don't know when you started doing it, but how intimidating was that to live code and because it's live, so that's how. So it makes it nice to make a presentation like this because
Yes.
you went through all these things in the video, so you can just kind of like scrub through the video and be like, oh yeah, I did that. Here's the thing it's doing.
Yes.
You make a presentation.
Yeah, that is, the nice part is that there's a very strong record that's more granular than like Git commits. It was fairly intimidating to begin with. I think part of what made it less intimidating is that I do have a PhD, so like even if I do dumb stuff, like at some point clearly somebody thought I was smart, so I got that going for me. That and I found it very helpful when I was learning things to see other people mess up. So I was like, okay, I am gonna mess up, and it's gonna be a valuable learning opportunity for everybody. And I'm not afraid to Google stuff, and I'm very clear on like the video descriptions. Like this isn't me telling you how to do things. This is me doing things that like I need to do anyway, and might as well do them in public. Yeah. I enjoy it deeply. We've got a great community, and I'm very happy to have folks that come and help out, especially because Python is not my favorite language. Like it's fine, but it's not my favorite. So it's nice to have people who are more Pythonic being like, oh, could have used list comprehension. But in a nice way, They're not like,
Is that line 100 characters long?
it's like having a linter that like talks to you. Yes.
It needs linters when you have a live audience.
Nobody. No, I love linters. Any other questions? Does anyone just have like just a dumb question about NLP where you're like, what's a word? Don't ask me what a word is. Nobody knows. Yeah.
How did Gustav get his name?
My husband and I had a paper at Interspeech, and it was in Sweden. And then we got Gustav. We were on a waiting list for like 6 months. We got him from the breeder, and we got him like a couple of weeks after. And so we were very Swedish feeling. And he's very adventurous. He's an explorer. And we should be like, oh, like Swedish explorers, I guess. Oh. What? All right. If you have questions that you would. That's the last slide. If you have questions you prefer not to ask in front of people, which is chill, you can hit me up on Twitter. My DMs are open. Banana. Wait, one last one.
I just wanted to thank you. We asked Rachel last minute to give us a speech, and she accepted that as usual. And she's back to her community for the third time. And I wanted to really thank you for coming back to our community.
Thank you for creating a community. You do. Stop breathing in that. Thank you. And it's going to be on Facebook?
It's on YouTube.
YouTube. Oh, even better. Fantastic. I'll add it to the list of them.